Hi Science Fair judges, I'm Finley Whyte, and I'm from Barber Academy. I'm excited to share my innovative and complex project with you today. Have you ever had pneumonia before, or even an infected wound? If so, you may have taken antibiotics to treat those infections. But how did your doctor figure out your dosage, or were you overprescribed? Let's take a deeper dive into the world of antibiotics. My presentation is No Time to Die, testing for multi-drug resistant bacterial strains in the home environment. My question is, of these 4 antibiotics, SXT, which stands for sulfamethoxazole and trimethoprim, Vancomycin, Cefotaxime, and Cefaclor, which is the least effective in inhibiting bacterial growth on a swab surface? When I was researching topics for Science Fair, I was struck by how many topics addressed antibiotic resistance as a growing problem in modern medicine. In 2022, the WHO estimated that 75% of in-hospital infections are due to antibiotic resistance. Moreover, PubMed says that antibiotic resistance is the primary cause of death for about 700,000 people worldwide each year. Also, I chose the topic because last summer I shadowed a doctor at South Calgary Family Practice. She saw a patient who had antibiotic resistance from repeatedly being prescribed antibiotics for infections. I saw firsthand the challenge of treating patients who present with the complex problem of antibiotic resistance. In order to state an informed hypothesis, I thoroughly researched all 4 antibiotics. I'll give you a quick summary. Vancomycin. It's one of the oldest antibiotics. It works by attacking the cell wall in bacteria. Cefaclor. Cefaclor is a cousin to penicillin, meaning it is a second-generation drug. Cefaclor is used to treat infections all over the body. Cefotaxime. Cefotaxime is a distant cousin to penicillin, making it a third-generation drug. It's used by hospitals to prevent infections in patients recovering after surgery. SXT. This is one of the most commonly prescribed combination antibiotics in the world. It's used to treat infections in immunocompromised patients, specifically people with HIV or AIDS, including NBA star Magic Johnson. My hypothesis is, if the antibiotic vancomycin is applied to the bacterial lawn, then the zone of inhibition will be the smallest and the least bacteria will be killed. I hypothesize that vancomycin will be the least effective because it is a first-generation antibiotic. Therefore, it may have the most exposure to environmental stimuli and other bacteria. For this reason, I hypothesize that vancomycin will be the least effective in inhibiting bacterial growth. Here are the materials for my experiment. I had several different phases, and in that there were several different steps. For each step, I used multiple different pieces of scientific equipment. Some of the most important and fundamental pieces of equipment were a vortex, an inoculating loop, petri dishes filled with nutrient agar, and of course an incubator set at 28 degrees Celsius that was used to incubate my plates for 24 hours. So, my experiment was performed over 7 days at a laboratory at Dalen Biologicals. I collected 4 different cultures of bacteria with 3 trials each. In addition, I had 1 control for bacteria. So, let's go into detail about my procedure. So, the first step was swabbing the surface and growing source bacteria. I used a metal inoculating loop that was sterilized with a heat source, also known as a lighter, and I transferred the bacteria collected by the inoculating loop onto sterile petri dishes. The second step was using the plate streak method to separate bacterial colonies and create pure cultures. I collected a colony of bacteria from the sterile petri dishes that I had incubated overnight, and I streaked it across a plate to separate the bacteria into its individual cells. Third, I made a diluted bacterial solution to diminish bacterial overgrowth and aid antibiotic efficiency. I made this by mixing the cultures of bacteria that I streaked in step 2 with water. I then streaked this onto a separate plate, and I put antibiotic discs on this plate. Then I incubated these plates overnight so I could let the antibiotic infuse into the agar, giving me a zone of clearance. The next day, I measured the zones of clearance created by the antibiotic discs on the petri dish. I collected both qualitative and quantitative data in my experiment. The color, shape, and size of the bacterial colonies were observed, described, and recorded. The radius from the antibiotic disc and the bacteria was measured using a ruler in millimeters. So, what did the data say? I have several interesting inferences in my analysis. Cefaclor was the most effective in inhibiting bacterial growth. This is evidenced by the largest zone of clearance. This is surprising as Cefaclor is only a second-generation drug, as my background research states. I thought SXT would be the strongest, as SXT is a third-generation drug and a combination medication. Oppositely, Vancomycin was the least effective in inhibiting bacterial growth. This is evidenced by the small zone of clearance. So my hypothesis was correct. I stated that Vancomycin developed the most bacterial resistance because it was a first-generation drug. Let's take a look at an outlier for a second. Bacteria 4. As you can see by my table, there is no bacterial growth. This was not accidental. Bacteria 4 did not have any bacterial growth. At first, I thought this was because the reproduction period is longer for this bacteria than the others. The reproduction period is called binary fission. But after 10 weeks, when looking at my petri dishes, there is still no visible growth for bacteria 4. Therefore, my current theory is that laboratory sterilization techniques were not followed correctly. It is possible that the 70% ethanol agent was still drying on the metal when it contacted the petri dishes, therefore killing the bacteria. So, who can this data be applied for? During COVID-19, immunocompromised patients and seniors were prescribed antibiotics to keep them healthy during the pandemic. However, as we now know, the overprescription of antibiotics leads to an increase in resistance long term. So, for many of these patients, their health risk actually increased. In addition, there are several things that you can do to prevent the spread of antibiotic resistance. First, you shouldn't be insisting for antibiotics when your doctor says you don't need them. Also, you should not be sharing antibiotics with anyone else or taking expired antibiotics. In addition, you should always be keeping common surfaces clean, keeping your vaccinations up to date, and handling and curating meat properly. I hope you enjoyed my presentation. I hope to see you at COASF. Thank you for listening.